So welcome to Center for the Promotion of Science, our science club. How the world would look like without mathematics? What do you think?
The world without mathematics? I think we'd struggle to understand it. I think humans have been doing maths because they want to understand the world. But the world would carry on, right? I mean, nature would still do its thing. But then maybe nature's using maths as well, even if it doesn't know it. But I think humans would struggle to understand how it all fits together. And maybe maths exist because we're curious.
So why do you love mathematics? So is it intuitive discipline to you, or?
No, I find it hard. I find it really hard. But I think that's normal. Some people are very good very quickly, but they're the ones that I think get upset when they find it hard. But most people, I think, find it hard. But I like it because it does give me ways of seeing the world differently. And it's not just understanding. I like it because it is beautiful sometimes. Sometimes it doesn't feel beautiful, and sometimes it feels messy, and sometimes I don't understand it, and I don't like that. But then I think that's normal as well, and so what I really enjoy is the satisfaction of understanding something, but also the way it makes me see the world differently and appreciate the way it fits.
In which way you see the world differently?
I think understanding the way that patterns occur naturally, but we can describe them and we can start to predict them. That's what maths does well. But it's not just about the natural world. There's this sort of abstract bit of mathematics, which a lot of people think is the pointless bit. But it has its own beauty of the way things fit together, and then you start to wonder whether we made up these rules or whether they are sort of somehow intrinsic to reality. And so there's this, are we discovering mathematics or are we inventing it? And I don't know the answer, but it's satisfying to find things that work very well and they feel like they work unreasonably well. So I start to wonder whether it is discovered a little bit.
Okay, thank you. And when was that you got interested into maths? Was it when you were a kid?
Yeah, when I was at school, but later in school, when I was 17 and 18 in England, I was studying A-levels, and you can do an A-level in mathematics, which is the last qualification you do at school, but you can also do a second A-level in further mathematics, and I think I took that by accident. But when I was studying this further mathematics, they told me new and exciting things like complex numbers. They told me about the square root of -1, which up until that point I thought that can't exist. And then they said, well, maybe if you pretend it does exist, then it's useful. And it was things like that that surprised me and made me realize that maths isn't just about here are the rules. It was more about a creative thing. Like someone had to be imaginative enough to let this number, which was imaginary, exist. And when they did, not only did it sort of solve some problems, it solved some real problems. It solved problems in engineering and electronics.
So what kind of problems? So what is the square of -1?
Well, the square root of -1, first of all, it's a problem because no real number that you square will become negative. They all become positive when you square them. So the first answer is that there is no square root of -1. But if you pretend there is, some people call it I, or some people call it J, an imaginary number, then it turns out to solve things, well, solving differential equations, which is the way you study how things change and move, particularly in physics and engineering. It turns out that you can't solve some of them unless you invent imaginary numbers. And dealing with, I was reading today about the developments of electric circuits when they discovered something about negative resistance, the way a circuit acted as if it had less resistance than 0. And to understand that, they had to use complex numbers, imaginary numbers. And that's how they get oscillating, that's how they produce microwaves. And so all that was only discovered because of an imaginary bit of maths that someone made up, or maybe discovered. That was an example of when I first got excited about the mathematics. It was when they told me something new, and it surprised me, but it was also useful. But that was when I was at school still.
Okay, so why do you think that children are scared away from maths in school?
I don't know, but I found it hard, and I'm sure that most human beings are. We get daunted by things that are hard, and so students that find it hard don't like it. But then some students who find it hard enjoy the challenge, and that's maybe what we have to celebrate, like the challenge that it is hard. It's not a surprise that it's hard, but it's worth doing. But I think more, we should probably remind the students that it's not just about rights and wrongs. A lot of students like maths because they know when they've got it right. But then the further they take it, the more about how do you know that you're right? How do you convince someone else that you're right? And that becomes a bit more of a human side, it's a bit more personal about the mathematics. And maybe that bit of maths is lost at school because you're told the rules, you do the questions and you get a tick. And that's part of mathematics, but it's not everything. That's not the creative. And so people doing new mathematics or trying to prove a theorem are not doing that. There's no answer in the back of the book and they have to be creative. It's much more like being an artist or a musician, I think. It's that sort of intuitive discovery that needs to happen. And I think if we can remind students at schools that sometimes maths feels like that sort of creative process, different parts of, or different students will find it more interesting.
You're also into music, so does it help you then to understand mathematics better? And what is the relation? How do you combine?
I don't think maths helps me do music. And I'm not sure if music helps me do maths. But the fact is that music works in a mathematical way. It's all physics in the end, it's things wobbling at certain frequencies. Harmonies sound nice because of mathematical relationships between the frequencies. And I end up talking a lot about the maths of music, but in the end, you can not know that and still make nice music and still enjoy nice music. But I think maybe you appreciate things differently if you do understand the sort of maths behind it. There's a metaphor about unweaving the rainbow, and someone talks about if you have to understand how the physics of light works to understand the rainbow, then you've missed the beauty of it. But I don't think that's true. I think with the rainbow, if you understand, you can see it's pretty, but you can also understand how it works, and with music as well. You can listen and it's nice, and you can also understand why it's nice or how to break the rules to change it. And so I enjoy music because it's music. And in the talk I'm doing later on, I'm going to talk about some maths which I learnt about because of a piece of music. But it's not, I could have still learnt about it without the music. And sometimes, well, I think the main thing for me is that we do music for a very important reason. We do it because it's nice, and we like it just because it's nice. It's not useful. It's just there. It's for our emotions, really. And most people think that maths is done because it's useful, and it is useful. But I think maths is also often done just because it's nice and because it's satisfying, and it's partly for our emotions. And so I often talk about how maths can feel like music, and that we should do it sometimes just because we're curious or because we want to know or because it's nice. And I will play a song in my talk, mainly just because it's nice, or at least I think it's nice. If everyone else hates it, that's their problem.
Okay, thank you very much.
My pleasure.